Okay, so the last part that I want to talk about this lab is just a couple of small things that are related to the actual calculation. The first one is that you have to use a specific heat, in this case, of the solutions inside your calorimeter, which is going to be a 1 molar HCl solution or 6 molar HCl solution. Okay, now the specific heat of these guys are not going to be the same as the specific heat of water, which is 4.184. The 1 molar HCl is going to have roughly the same one, fairly similar, so 4.1 joules per gram degree Celsius. So please use this number if you're using 1 molar HCl. If you're using 6 molar HCl, it's going to be quite different. So you're going to use 3.1 joules per gram degree Celsius. Use these numbers in your calculation. If not, you're going to be marked wrong. Second thing that's important is that the reaction that you are given for the experiment today is set up so that one of the reactants is limiting. Okay, so an example is if you're reacting 0.15 grams of magnesium plus 25 milliliter of 1 molar HCl, you can use stoichiometry of these reactions to figure out which reactant is limiting. I'm going to leave it up to you to do that at this point because I assume that you know how to figure out limiting reactants in a reaction such as the one given today. And in this case, the limiting reactant is going to be magnesium. Now, so the key there, of course, is that the intent of the lab is to make sure that magnesium is your limiting reactant. So you don't want to add too much magnesium or too little HCl in your experiment, because if you do that, then your limiting reactant might actually change, and it might be that the HCl becomes your limiting reactant instead of the magnesium. What do I mean by not too much? Well, you know, if it's asking you for 0.15 grams of magnesium, you might want to go 0.152, that's okay, it's not that much more. But if you go 0.350, now that's quite a bit more. That's more than double of what you're being asked to put in, and so that might completely change the nature of the limiting reactant for the reaction. Now, the other thing is that remember that what you're calculating there is Q at the very beginning, and Q is going to be proportional to the mass that you have and the delta T, right? So if you have a lot of mass in your reaction, right, that might generate quite a bit of heat. That heat is going to result in higher delta T, okay? But remember, at the end, everything is going to be divided by that mass again to give you the heat per mole of quantity. So you shouldn't worry too much about getting a number that's a little bit different, because in the end it's going to be divided. But as long as you pay attention that the delta T goes up only if the mass goes up. If the mass goes up and delta T doesn't go up, then there's something that's quite strange there. Or the delta T goes up without the mass changing, then something is a little strange there. So you need to check your data with me before you leave, just to make sure that everything looks reasonable. And you know, try to do that calculation using Hess Law with the metals that you might be working with, zinc or magnesium, right? Just to see if you can manipulate those reactions so you can get the enthalpy of combustion for the metal in the end.